Hi everyone, welcome to another video, and today we're going to discuss about a new question called maximum consecutive ones 2. In our previous question we solved the maximum consecutive ones 1 using prefix sum, and this one also we're going to solve using prefix sum. So now let's read the question. The question suggests, given a binary array nums, return the maximum number of consecutive ones in the array if you can flip at most 1 0, right? So now let's examine what the question says. So it says that we will be given an array called nums, and that nums is a binary array in the sense it will contain ones and zeros. So let's take our second example, like 1 0 1 1 0 and 1. In this particular case we have to count the number of ones, right? So if we start from index 0, that is 1, and we can flip at, at most 0 to 1. So if we convert this 0 to 1, our count will become 2, then 3, and then 4. And we cannot convert more than 1 0, so we cannot convert it. But if we calculate again and again for other consecutive ones, maybe starting from index number 1 to index number, we only can go up to index number 3 because we already converted 1. If we start from index number 2, then we can go up to index number last index because we can convert the second 0 into 1, right? So and our maximum will become 4 ones. So that's the result. We have to return the length of the maximum length of the consecutive one subarray, continuous subarray. So now let's see how we can implement our prefix sum to get the answer. So now let's consider another question where nums is a binary array that contains elements like 1 0 1 1 0 1. Just add one more 1, and the indexes are like 0 1 2 3 4 5 and 6. Now what we're going to do here, we're going to keep calculating our number of ones from 0th index, and since we can flip at most 1 0 to 1, so let's declare a variable called k equals to 1, right? So when we go to index, so if we start our prefix sum from index 0, our sum will be 1 here. And when we go to index number 1, we see, because we got a 0 here, and we check that if k is 1, that is greater than 0. So we're going to calculate that particular 0 as 1, so it will become 2, and simultaneously we need to decrease our k. So now k becomes 0. So when we get a 0 next in that array, we cannot convert it or cannot flip it to 1. Okay, now since the second index item is 1, we're going to keep calculating. So our running sum, our prefix sum will become 3 for index number 2. Our prefix sum will become 4 for index number 3. And when we go to 4, we cannot go ahead because our k will be 0 at that point. So we cannot flip that particular 0 into 1. So when we reach up to index 3, our max will become 4. Now when we reach a next 0 and our k is 0, because we cannot convert, we have to start recalculating, right? So what you're going to do here, we have to reset our k to 1, and we have to calculate, because we already considered this 0, so we have to calculate up to from index number 2 from here. So what's going to happen now? From here we're going to again start our prefix sum, that is going to give us 1, then 2. Now when we reach again at 0, we can flip it because k is 1. So we're going to keep calculating here our prefix sum. So prefix sum become 3, and we need to make k minus minus, and then again the next item is 1, so we need to keep calculating. So you're going to get 4, and at the last index we're going to get again another 1, so our prefix sum will become 5. And now at the same time we're going to keep comparing our max with the current max. So the current max become 5 because 5 is larger than 4. We can update our max to 5, and 5 will be the answer. So it's a simple one. So every time we're going to do our simple prefix sum from left to right, and every time we're gonna keep track of the number of zeros we are flipping, and the time we flip the 0, we make the number of item we can flip to 0. And whenever we get an item in that binary array that is the next 0 or 0, then again we have to reset our k, and again we have to recalculating our prefix sum. And the same time we just have to keep track of our calculated max, as simple as that. So now let's just implement the same using JavaScript. So I have created a function called mco2, and so first thing first, we're going to keep creating our variables, create necessary variables. So first one will be let k, because we only can flip only one item. Our k will be 1, so that we keep track of how many items we flipped. And then we're going to start our index or for loop from I, right? For loop, or we can do our while loop. It's the same thing up to length. We can do it with a for loop or with a while loop, but here we're going to do the same looping through while loop. So we're going to start our index from 0, and we have to go up to the length of the array. So now let's create our max variable, and where we're going to keep track of the max, and we're going to initiate it with to 0. And then our sum, right? We don't have to create sum. We just have to keep adding, so it's fine. Anyway, now let's create our while loop. Again, we have to keep track of the last index where we flipped, so that we can reset the index, right? So let's keep track of that as well. Last index, we're gonna start from 0. Now while I less than our array will be nums, the input, right? Nums. So nums dot length I plus plus. So this will create our loop. Either you can do it with a for loop or with a while loop. It's fine. So now we're gonna keep calculating our um, sum, right? So yeah, let's create a variable, because we cannot update our array now, because we're gonna keep moving from 2 and 4. So we have to keep track of our running sum. So let's create a variable running sum, and let's start it with 0. Now first thing first, if nums of I not equals to 0, right? And yeah, not equals to 0, then running sum, we're going to add running sum plus nums of I, right? For everyone you're going to keep adding. Only thing, our conditions will change when we get 0. So second condition will be else if nums of I or we can write like else if not nums of I and our k is greater than 0, right? If k is greater than 0, we can flip it or we can count that particular 0 as 1. So still we can do like running sum plus or equals to 1. We can add 1 to running sum. Simple, right? Next case is when we find a 0 but we cannot flip it. At that time we have to reset the everything. So let's do that. Else if nums not nums I and k equals to 0. Here we have to reduce our k because we consider 0 as k as 1. So we have to reduce our k. So k minus minus. And then here we have to reset. So we have to move back our I. So I will be last index. Oh, here we have to save our last index the first time we flipped. So last index equals to I. Okay, the ith index. So here again we're gonna move our index to last index. We have to reset our k to 1 or we can do k plus plus. Make it k plus plus or just adding 1 to k. And also we're gonna start counting our prefix sum from the completely new prefix sum, right? So we have to reset our running sum. Sum equals to 0. Perfect. And every time, right? Every time we are getting a 1, right? Every time we're getting a 1, running sum plus k minus. So yeah, every time we're going to keep track of our max equals to math.max and running sum. So our max will be keep updating every time we come out of any if-else condition. So it will keep track of the maximum number of ones or maximum number of one in a substring or a consecutive substring. So at the end, we just have to return max. This should solve the question. Let's try to run our test cases. Perfect. Now let's try to submit it to LeetCode as well and see how it performs. And the test cases, perfect. Submit. One of the most efficient one. So that's that. Thank you for watching, and let's see. We may solve another prefix, one or two prefix sum. Then we're gonna go for our next pattern. So see you in our next video.